Hello everyone. In this video we are going to solve the problem number 1.54 from Irodov, and that is related to kinematics. So let us first understand the problem and then we will solve the problem step by step. A cylinder rolls without slipping over a horizontal plane. The radius of cylinder is equal to small r, and it is asking to find the curvature radii of trajectory traced out by the points A and B. Okay, so this is the cylinder which is rolling on the surface without slipping. So basically if we talk about at the bottommost point, it will have the velocity in this direction and the velocity of omega r in this direction, and as it is rolling without slipping, so we can write v is equal to omega r, because net velocity at the bottommost point is 0. Okay, now it is asking to find the curvature radius at point A and at point B. We know that curvature radius we can find out from 1 plus dy upon dx whole square to the power of 3 by 2 whole divided by d square y upon dx square. But in order to apply this particular equation, we should know y as a function of x. Okay, what is the y coordinate, how the y coordinate of point A is changing with respect to the x coordinate. But in this particular problem we don't know y as a function of x. So again we will use the different methodology to solve this problem. So let us first talk about point A. So basically the point A will start from this particular point and it will move in this direction and it will go to the bottommost point, and again it will start and it will go like this. So at any point we can find the radius of curvature using the velocity in the tangential direction and the perpendicular force. If we talk about point B, then point B will go in this particular direction and then it will move something like this. Okay, and for this particular case also we can find out the tangential velocity and the perpendicular force to find out the radius of curvature. So radius of curvature we defined as mv square whole divided by f perpendicular, and here the velocity is in the tangential direction. Now here what is the tangential direction? So the velocity in this direction, okay, and the resultant velocity is equal to v due to the translational motion plus omega r due to the rotational motion. So basically at point A we are having the net velocity of 2v, okay, and because v is equal to omega r for the pure rolling case. Now it is given that the velocity in the tangential direction at point A is 2v. So let us substitute it here. So we will get m into 2v whole square whole divided by what is f perpendicular here. Okay, so f perpendicular we can write it as m omega square r. Okay, and in this particular case velocity is equal to omega r, so we can write f perpendicular is equal to mv square by r. So let us write it here small r, because radius of cylinder is given as small r. So let us substitute the value of f perpendicular here. So we can write mv square by small r. So from here we will get radius of curvature is 4 into r at point A, and let us denote it as radius of curvature at point A is equal to 4 into r. Now let us talk about at point B. At point B we will have the velocity in this direction due to translational motion, and due to rotational motion we will have the velocity of omega r in this direction, which is equal to v. Okay, so the resultant velocity will be in this particular direction, which is tangential to this particular curve. So that resultant velocity will be root 2 times v, because both v and v are perpendicular. So the resultant velocity we can write it as v square plus v square under root, that is equal to root 2v. Okay, and we are having the f perpendicular, so centripetal force will be in this direction, that will be m omega square r, and if we take the component that is perpendicular to this particular velocity, then we will get it as m omega square r into cos of 45 degree, because both velocity are same, so this angle will be 45 degrees, so this angle will also be 45 degree. So if we write the radius of curvature at point B, that we can write it as mb square whole divided by f perpendicular. What is the velocity? That is equal to root 2v. So we can write root 2v whole square divided by f perpendicular will be m omega square r cos 45 degree. M omega square r into cos of 45 degree. And here omega square r we can write it as v square by r, because omega r is equal to v. Okay, so from here we will get 2 times v square whole divided by v square by r into 1 by root 2, so we will get 2 root 2 r. So the radius of curvature at point B, we can get it as 2 root 2 r. So this is the radius of curvature at point B, and this is the radius of curvature at point A. I hope the entire procedure is clear. Thank you.